Hello, I'm Jason Breland, and over the course of this video I'm going to be explaining to you briefly about the pilot study we've conducted and the results we found. To begin with, the collaborative virtual environment we created was inspired because we saw many people who were working in virtual environments merely had a one-man show, that is, they were working by themselves, or they'd have a marathon where they work linearly. One person does the modeling, hands it off to the person who does the lighting, etc. As you can see with the two viewports here, the host is on the right and the client is on the left. They've joined together to work concurrently. That is, they're going to be working in the same virtual environment at the same time, on the same building. As you can see here, this is the hallway of the building we're going to be working on. Let's skip ahead a bit so you can see what I mean. You'll notice here the floor of the building. The two subjects are working with modules. Each section's broken up into about 4 foot by 8 foot sections, or repetitions thereof. Some are larger. And you can see they're holding shift and copying these objects just like in 3D Studio Max. In this way they can create one section of, say, marble floor and shift drag it to create multiple copies and fill up the entire floor. One of the drawbacks of this, however, is that each object has a unique identifier number and possibly a name. This can become very cluttered if many objects are present. In the future we hope to reduce the total number of objects so that there will be less clutter as far as object identification, and also for purposes of expediting the design process. What we've seen so far from these two particular subjects is they've chosen a divide and conquer technique. That is, one chooses to work on this portion of the floor or wall while the other works on another section independently. That's fine, but we wanted to mix it up a little bit. So you can see here one of them starting to struggle with the stairs, the client. In fact, he's actually having kind of a difficult time getting it lined up. These stairs are broken into 3 different sections, top, middle, and bottom. Now, working by himself, it's getting rather difficult to see if it's lined up and manipulate the object. This was intentional. In this manner, the two will have to collaborate more directly, and that one either moves around and gives feedback, or they both attempt to work on the same object at the same time. And we really kind of wanted to see what happened. What we found was pretty interesting. The subjects are now communicating verbally. They're talking back and forth about the object, figuring out which direction it needs to go. And what we found was, by having 2 perspectives, the 2 subjects could more quickly identify the problems and manipulate the object. This allowed the subjects to get the stairs completed in a fraction of the time it took them to working independently. In addition, they felt much more confident about the task. They felt like, since they had another person working with them, if they got hung up on a small problem that they overlooked, the other subject would help them. In this way, there was a very positive mental response from the subjects while working in a collaborative environment as opposed to by themselves. You may notice that the dots and names of the objects are a static size. This becomes problematic as you zoom out. The object names and dots become more and more compressed together, and it obstructs the view. This can make getting the exact position and location of each object into the correct place very difficult, especially when you're dealing with large objects and you're having to make small, minute changes here and there, as was the case with the stairs. The subjects encounter a similar problem when dealing with the roof cap. As you'll see here shortly on the left, the client enters review mode, thus hiding all the dots and names of the objects. This allows him to get a more clear view of what's actually going on and how the objects meet up with the other objects. He then relays the information back and forth between him and the host so that they can more easily line up the roof cap and get the object completed in a timely fashion. Once the roof cap's in place, we're done with the model, but we're not done with the virtual environment yet. What we're going to do next is go into a 4D playback of how the building was constructed. This has several applications. Firstly, because the order in which the objects were created was preserved, we get to see exactly how it was that the building was created, starting with the floor, then the walls, roofing, etc. This allows us to evaluate the design process and see if there's any inconsistencies in the design. Another application is that if this were an actual building, you could create the objects in the order in which the actual building would be created, and you could get a 4D playback of the construction site of an existing building.